Welcome back to lesson 5, the cross product. We're going to do examples 3 and 4. So the first question, or the first example, says determine the area of the parallelogram defined by the two vectors. So, again, given these two vectors here, we have to remember that the area of the parallelogram is really the magnitude of u cross v. So what do I need to do here? I actually need to find u cross v. So I'm going to do that right now. So I have, I, j, k, I, j, k, and then here I'm going to have 4, 5, 2, since u is first, 4, 5, 2, and then what I have second, I'm going to have here 3, 2, 7, 3, 2, 7, and I'm going to cross them, so I'm going to do this, minus this. For the first coordinate, then I'll do j next, so this, that multiply together, times this, then I will do the last one, so it's going to be this, multiply together, minus this, and so I know that u cross v is actually equal to, so it's going to be 5 times 7, which is 35, minus, 2 times 2, which is 4. Then I'm going to have 2 times 3, 6, minus 7 times 4 is 28. Then I will have 4 times 2 is 8, minus 3 times 5 is 15. And so what I'm going to have here, u cross v is really going to be 31, negative 22, and negative 7. So I actually know then the magnitude of u cross v will be equal to, if I square these and sum them, and then square root them, I will get its magnitude, and so when I do this, I get the magnitude of u cross v is actually equal to the square root of 1494, which is approximately, put this in my calculator, 38.65 units squared, since it's the area. So the area of that parallelogram is equal to approximately 38.65 units. Okay, if you've done that, we can also find the angle between the two vectors. So to find the angle between the two vectors, same as before. Now because magnitude of u cross v is equal to the magnitude of v sine theta. If I rearrange that formula and isolate for sine theta, therefore sine theta is equal to magnitude of u cross v all over magnitude of v. Well, I have that. Now the nice thing is I actually already have this answer here. This answer is actually the square root of 1494, as we saw in example 3. I will do the magnitude of u over here. Magnitude of u will be 4 squared plus 5 squared plus 2 squared, which is equal to 16 plus 25 plus 2, which is square root of 45. I'll also do the magnitude of v. Magnitude of v will be 3 squared plus 2 squared plus 7 squared. So if I do this, I get the square root of 62. So I've already got all those, so I can just plug them in my formula. So here we go. I know that sine theta is equal to the square root of 1494 over square root of 45, square root of 62. I do sine inverse of this guy here, and so I get my theta is actually equal to approximately 47 degrees. So the angle between u and v, the tails of them, is 47 degrees. The problem with this method 1 is the cross product is not fun to do, so this always takes a little bit of work. Dot product is much easier. The other problem is cast. So cast tells me this is one possible answer, but I can also have another possible answer in quadrant 2 between 90 and 180. So how do I know if this is the right answer? I can then do the dot product and see if it's positive or negative. If you see, if we do the dot product here, because these two vectors here are all positive, I can see the dot product will be positive. So that means that it will be 47 degrees, but if the dot product was negative between these two vectors, then I'd actually have to do cast to find the other answer. So really the dot product, but the dot product is nice because it'll always give you the correct answer, whether it's between 0 and 90, it'll be positive, and if it's between, if the dot product is negative, then it'll be between 90 and 180, and the dot product, or the dot product formula actually works out for that. So I would never use this formula here, but I can show you that this actually does work.